Hello, in today's video, we will go over a topic which I believe to be very fundamental and crucial to our everyday lives, radio transmission and reception. Specifically, we will discuss how an AM transmitter receiver works, as well as how quadature amplitude modulation works. Concepts of extreme importance as shown by the images on left and right, where we have a radio tower transmitting radio waves to core radios and a Wi-Fi transmitter sending information to your computer. So to explain how an AM transmitter works, we have an audio signal, which in this case is a sinusoidal function, and we take that audio signal and we mix it with a carrier signal. The carrier signal is usually at a higher frequency than the audio signal, as you can see here, and we multiply the two, and we get this AM wave where it has the same frequency as the carrier signal, but the amplitude varies based on the audio signal, which is called amplitude modulation. Now that we know how amplitude modulation works, we can now build an AM transmitter according to the schematic. To briefly explain, we feed an audio signal into a transformer, which is wired in series with a powered 1 MHz oscillator, and we do this to impose different voltages corresponding to the audio signal into the 1 MHz oscillator, and by doing this we create 1 MHz waves with different amplitudes, and thus we have amplitude modulation. For this transmitter, you will need an audio plug to USB-C cord, a breadboard, an audio transformer, a 1 MHz oscillator, a 5 voltage power supply, and alligator clips. The first thing we'll do is attach our audio source to the breadboard by connecting our alligator clips to the audio plug. So if you don't know, the audio plug, the bottom terminal is ground and the upper is audio signal. So I'll attach these alligator clips accordingly. So we have our audio connected to breadboard. Next, we will connect the transformer to the breadboard. Now we have our transformer attached to the breadboard. Now in series to the transformer, I will place the 5 voltage from the power supply. Next I'll place the oscillator into the breadboard. And wire the other end of the transformer to the crystal oscillator. Next, I will attach the ground wire from the power supply to a ground rail and attach that ground rail to the transmitter. Or to the oscillator, my bad. And then I'll attach the antenna to the output terminal of the oscillator. And now the transmitter is done. So right now I've added a 9-volt battery to the power supply, and I have added an audio source to the breadboard with the phone. And now we're going to test this device with the radio. Just an example of how the radio works. I'm going to turn it on, and I can alter the capacitance to change the frequency it's operating at. So now, lower the volume here a bit. Going to turn the sound on, and I can change it to the right signal. Which tends to be at the very end of the capacitance. And you can notice when my hand goes near the capacitance, if the whole circuit's changing, when the audio clip is closer. You can see the transmitter is working. So in parallel to the speaker of the radio, I have wired it to a voltage divider circuit, which is then wired to the Arduino, and by doing this we can record the voltage of, we can record the audio signal from the speaker and the radio, and when I turn it on, we can get the audio signal on this plotter of the Arduino software. So I've also wired an Arduino to the transmitter and have code written to convert text to binary ASCII and then to transmit that. So once I run this and turn the transmitter on, you can hear that the speaker is basically outputting ones and zeros. And it's kind of clear that there's ones and zeros being displayed analogous with the speaker onto the plotter. And this is obvious by both the change of the frequency of the wave and the increase in amplitude. So now I'm going to try to transmit hello 101 to the receiver and decode it. And I do this on repeat. So from a transmitter to the receiver, I have possible readings of what is transmitted, and each is shifted by 1 bit, 2 bits, or 3 bits because they might not be in line when I'm transmitting and receiving. So right here you can see the closest one being he.lm.9.9, and this is slightly off because of probably noise and other factors, and you can kind of see it's almost transmitted. And there's also a 101, so you can see parts of it are being transmitted. So now I'm going to explain the AM receiver component. So first we have an antenna leading into an LC bandpass filter, and the way this works is by thinking that inductors only allow lower frequencies to go through them, and capacitors allow higher frequencies to go through them, so we can tune it to only allow a certain frequency to pass through the circuit and all other frequencies go to ground. And then we have a diode to rectify the desired signal we have in the circuit now, and after that rectification we can filter out any of the carrier signal and get our audio signal. So now we'll go over Quadature amplitude modulation. Similar to amplitude modulation, we generate a carrier function, but we do something interesting with it. We shift it to the right by 90 degrees to get a cos function and a sine function. As shown in the equation on the left and on the image on the right-hand side, we divide our message in half to mix each half with its respective sine and cosine function, and then we transmit the sum of the next signals. If we want to get our original signals back, we simply multiply each signal with their respective cosine and sine function and do some filtration, and by the math shown, we get our signals back. So the benefit of Quadature amplitude modulation, as you can see in the visualization, is that we can send more information per wave packet, and we can even do more in 4 different locations. We can do like 16 or 256 if we change how many levels I2 can occupy. So that's Quadature amplitude modulation and amplitude modulation and the basics of them. I was going to try to do a Quadature amplitude modulation transmitter build, but that would have been a bit more money and I'm lazy. So don't forget to like and subscribe.